first, I don't think this was on the version that I sent out to you, but we have an exam scheduled for next Monday. And this is the breakdown of the exam. You know me, I like to plan things way in advance, so you know that way before the weekend I will have the exam already ready. And I will be sending out more guidance, because I usually do. I think, I'd like to tell them what maybe the rubric looks like I did with you this time. So you're not going to get any surprises. There'll be computational questions on there where you find subgroups. I'm going to show you how to do that today from today's lecture. True-false questions, you'll see some of them today, where we have examples where we're starting to see. Can you give me an example of a finite non-commutative group? Yes, you can. Dihedral group of 4 elements. So there's things that you already have seen where there are examples where those true-false questions will fall into place. One proof that you've seen before where I already have posted solutions, I think there's that will definitely be there. And one proof you haven't seen before, that'll be a 20%. So the way I look at this is, if you just go through the material and the content that's already posted, and you review the notes, and you review the videos, and you review everything I've assigned already, and you backtracked and checked everything I've done, then you should be able to get an automatic 80% from that. The 20%, keep in mind, it's not, I'm going to get a 0 on that 20%. That's not true, because that 20% also has the rubric next to it with the know and the show and the breakdown. So, but I think as we go through this, we always have to see how you tackled the something you haven't seen before. So I don't expect, and that's why the rubric is set up the way it is, that you're going to have a great proof because you had an aha moment in this room. I guess we'll be taking it in this room. It might not happen for you that day. So that's all accounted for in the rubric. Just how you break it apart is what I'm more interested in. So any questions on that?
Full period?
Say again?
Is it going to be the full period?
Oh, yeah. I remember we told our real analysis professor that we need, it's not possible for us to answer these kind of proofs during the class period. And he said, well, what's everybody doing on Saturday? Because I think I can stretch out the time for you. He didn't say, I'm going to shorten my test. He quietly told us that he'll give us more time. I've never felt what it feels like to have a hangover without drinking first. That's what it felt like taking his test. So on the quiz that you just got back, one of the things as part of, I think, learning how to write proofs, it's the first time many people in mathematics learn, because a lot of what we do is computational, and there are procedures, they're algorithmic, and if you're good at seeing that algorithm and that structure, you don't really learn. You kind of watch someone do it and you imitate them. When you're writing proofs, that I felt like for the first time in my life I was really learning. And part of that learning process is learning how much time it takes to learn it. Remember I told you about the guy that said he quit doing physics because proofs took 4 hours? And in my mind I was thinking, they only took you 4 hours? So somewhere in his education he hadn't figured out that it takes a certain amount of time. And I've seen this over and over from students, that they figure out, they need more time, and when they figure out how much time it takes and they've reached that stabilization point, they feel that the material has gotten easier. So some of it was their expectation of how much time something should take. You have to start them on the day that they're assigned or the day after. You absolutely have to. You cannot wait. This was something, I never had this problem. I had a lot of problems, but this one I didn't, because I don't like to procrastinate. So I'm the opposite of many of my colleagues or friends in grad school where we were learning how to write proofs. They would wait till the day before, but I would start them the day they were assigned and start thinking about them. And I think that's what saved me. We dropped like flies in grad school. We all started out in the same cohort, and at the end of grad school there was only 2 of us in my cohort left. I was one of the 2. And it was not because I was smarter than the rest. I started the problems earlier. And I had actually thought about this quite a bit, and I was looking for predictors of who does better in proof writing classes, in any class actually. And you would think that it's people who do the most homework, people who spend the most time. The number one predictor of students' work in my classes has been how early they start. And I actually had a chance to document this and check this for myself. I don't have the graphs anymore, but it was a good predictor. And in fact, you could actually see that from the analysis I did, if you started it 2 days before it was due, you were guaranteed an F. This was in a linear algebra course. I did a little analysis to check it. So it is, I think it's how you look at it. Like, you have time to digest what the question's being asked. You have time to ask the right questions. You just look at the whole process in a different way if you start it earlier. So that's my first tip. And that's a great tip, because if you can't access the proofs because there's something muddled up here, that's more alarming than, oh, you just have to start earlier. That's a quick fix. So that's my first suggestion. You might find you actually have to spend less time if you start earlier. So I can also help you with this if you you know yourself and you know you're a procrastinator. I've actually set up things with students where there's text alerts going through back and forth with me and the student, so that I will come in and ask them, hey, I'm here on Friday. Give me what you got. So they have something to shoot for and break it up. And then after a while, it becomes natural. So it's not like, what do they call that? Psychological props. It's a psychological prop. We have them in our weight management clinic. We actually have these time boxes where you can't open up your food because it's locked automatically. So it's a prop, but it teaches you like how to structure that. So I can help you with this bit, and you can just let me know. You can also send me drafts of your homework, and I will look over and send back information and feedback. How many of you have sent me drafts of the homework so far? What do you guys think? How fast do I send you feedback? Same day, probably in the same hour, probably within the same couple minutes. So I actually take that picture of the homework and I stick it into Word and I start messing with it and pointing arrows to different directions, so you can get good feedback from me and count on me. Again, there's no reason for me to stand here and do this job unless I like doing the job. So don't feel totally comfortable approaching me about any of your work early if you want to show me anything. The only case I would have that's a problem is if you send me something the day of the quiz. I do feel like I want to answer your questions, but sometimes, like today, my heart was in my throat here all day. Somehow, with our schedules, the way it's set up, the day we have our teaching, they try to pile everything else on that same day. We saw so many teachers in here, so you guys know what I'm talking about. Sometimes I can't think straight when I get here, but I'm trying. But I'll be much better if you ask me at least a few days in advance so that I can give you that feedback. So one of the things is not to beat yourself up about it. So I think that in other courses, sometimes you feel like, well, I should have studied more, I should have looked at this more, I should have done it this way. Part of the learning process for writing proofs is figuring out how much time that is needed. That's part of it. So when you learn to write proofs, you're learning how to do that. And the other part is learning how much detail is required. So if you're getting feedback on this quiz where you didn't put enough detail or you didn't say, then you can figure that out. That's part of it. So you first have to identify that gap and then figure it out. If a good way is imitation. I see some of you imitating my writing. I'm totally flattered, but I have to tell you that my writing is actually a minimal writing. So if you're imitating me, you're getting at least the bare minimum of what you're supposed to be writing. If you're writing a bit more than me, that's probably better. Putting in more detail of what things. One key thing is you have to indicate where you're using the hypothesis. Where are you using finiteness? That was the big part of the hypothesis. When you're drafting your proof for the first time, you have to think about what will happen if this is not there. I think I kind of talked to you about that when I was showing you how I construct proofs. Like, why did they put finite here? Is this not true if it's not finite? So those kind of questions pop into my mind now automatically. But when I started writing proofs, it wasn't there like that. I basically used to stare at the question for I thought a long time, but it was probably about 5 minutes, and then get frustrated. But now I ask those questions like, oh, why is this in my hypothesis? Where am I using it? Why are they telling me this? And I try to identify in the proof itself where I've used it. Right here's my hand telling you I've used it. So that's a good way to say I have the right amount of detail. I'm not sure, reading over your quizzes, if there was a misunderstanding on some guidance that you received or a misunderstanding of a group that is finite, but a lot of you were using this set and saying that G was equal to that set, and that is not, in fact, true. It must be it must be a finite group because H is in G and G is finite, and it stops. That's true. And it is a subgroup that we're going to prove. I don't know if the quiz problem that I gave you is used to prove that, so you can't use the fact that you have to prove that first. But what I saw in a lot of your quizzes is a lot of you were saying G was equal to this, and that is not true. And the Klein group, we're going to go through that today. The Klein group, the 4 Klein group that I showed you the other day, is an example of a finite group that is not cyclic. So just because it's finite does not mean that it's cyclic. So another thing I've done is, here I give you an example. The 4 Klein group is what popped in my head now, but here's an example of a subgroup that is cyclic that doesn't give you the whole group back. So, and this is a good idea too. When you're writing your proofs, 2, 4, 0 I get for H, and if I select X equals 4 in H, it's closed, it has all that. So this particular group, subgroup, does not generate the whole space, the whole group, right? So that's an example. So when I'm constructing my proofs and thinking about these things, I always think about examples that fit in too. Can I come up with an example of this? Or if I make a statement. So I've made some of similar statements as you too, where I go G is equal to a cyclic group. And I stop and pause and say, is that true? Can I make a beast of a group that is finite, that isn't cyclic? So I start thinking like that. Those are questions that you ask yourself as a mathematician who's used to doing proofs. So what I saw on some of your work is that you constructed and didn't say G was the cyclic group. You said, let me form this group. And it turns out that this group is finite, and then you can go and proceed as in the same manner that I did. If the group is finite, then something has to repeat inside there, and then they have to have equal exponents, and then so forth. So you could do that. Say, I'm going to take an element A from the big group, and then look at the powers of A and make a set, and then restrict myself to that set, and those things have nowhere to go, and therefore there must be 2 powers that are equal, and then you proceed as so you can do that. And I think I couldn't figure out from your writing if there's a misunderstanding that this is not the whole group, or if you're trying to do this, and that was unclear on some of yours. But you cannot say this, that's not true. Another thing that I was guilty of this one a lot. I would always go to people who I felt were more advanced than me or had some special ooh around their head that I didn't have, and I would work with them. But there's really effective ways to work with people, and there's ineffective ways. So if you work with someone who you feel has the ooh going around their head, give yourself time to digest what they're telling you. Again, it's starting early. So there's a lot of value in doing this. I've mentioned my colleagues' names to you because I've learned from them. So there's a lot of value to that, but I'd give yourself time to digest what they're telling you. And we all have Skype and other ways to contact it. I think this is a fabulous idea. But I would meet with them as early as the day after problems are assigned, just to see what they think or what they have as guidance. Think of examples to fill in their explanations. If someone's explaining something to you, like, oh, well, here, you can form this set, A squared, A cubed. Can you give me an example with a group that shows me something like that? So ask them for real examples along the way as they're explaining things to you, so that you can get your hands on it and see what that looks like. That's a good way to slow them down and help you digest what they're trying to explain to you. Ask a lot of questions. Don't let them get away with anything if they're trying to explain something to you, because it helps them too. Right? Helps them clarify their thought process too. So you're actually helping them by asking questions like, I don't get what you mean by that line. Anywhere where you see a gap and you don't fully understand, sock it to them. Go and ask them more questions. If you're helping someone, ask them those questions back. What do you think? Do you think the statement's going to be true if I relax the condition of finite? I mean, these are great questions to ask people. People have done that to me too. What do you think? Is this going to be still true? What if I make this into a ring? I'm just making something up. So you make another thing. Is this still true? So you can start asking questions like this to the person that you're helping. So you can go on both ends. And those of you who teach probably do this all the time, right? Students probably get annoyed with you because you don't actually show them how to do anything. When they go to your office, you make them think. I'm sure you do it. Can you think of an example of this set here? These are kind of questions you can ask people if you're helping someone. Can you think of an infinite set that would make my sentence untrue? That's another twisty thing that people have done to me. The goal for anybody is mastery. So keep thinking, I just want to master how to write a proof, not how to resolve this proof, but how to just master writing proofs. Because what you'll find is if you can write a proof in abstract algebra, you can also write it in real analysis. If you can write it in real analysis, you can also write it in topology. It doesn't matter what the topic is, you'll be able to shift to the other discipline and ask those same kind of questions and construct your proof. So if you master it, then you never have to be worried about it again. It's done. Not just resolving today's challenge. And then one last piece that I noticed on this quiz is anytime I need to show there exists, in this particular proof, you had to show there exists an n. And I think I hammered you if you didn't put there exists inside your no, or you show that you actually had there exists. There's a standard procedure that if there is a there exists, that means you have to produce it. Here it is, here's my n. So at the last line of your proof, you should have n is equal to this, right? That's the last line. You get these there exists all the time in real analysis. So in real analysis, you'll have there exists a limit. Here it is, here's my limit. I took a subsequence, that subsequence had a limit, that was my candidate for the x, and I'm going to prove to you that the x actually works, and at the last line you put my x is the limit of this subsequence. So you actually have a constructed proof that gives you that there exists. Okay, so that'll help you at least with the, I don't know if that made sense for those of you who were didn't understand that, but if you need more guidance on the there exists, anytime the show part says there exists, your last line is here it is. So you actually have to find it somewhere. Okay, are there any questions on this?